Okay. We'll start with semiconductor electronics. See, we'll start with first of all the different types of material. The first one is we have conductors, types of material. Types of material. So in this material, he says that first one is conductors, then insulators. Conductors, insulators, then semiconductors, then dielectric material. Then the last one is superconductors. Okay, superconductor. So first is what? Conductors, insulators, semiconductors, dielectric material, and superconductors. What are conductors? Means the material which allow the flow of current. Okay, material which conduct current or which conduct current. Which conduct current. So what are the examples? Best examples for this is metals. These are metals like copper, aluminium, and silver and gold. Okay, these are the good examples of conductors. Then insulators. Insulators means material which do not allow the passage of current. Material which do not conduct current. Which do not conduct current. What are the examples for this? What are the examples? Wood. Yeah, they are wood. Then plastic. Wood, plastic, and rubber. These are the examples of insulators. Then what are semiconductors? Material which allow small amount of current. Material which allow small amount of current. Small amount of current. What are they? Example for this is silicon and germanium. In all the electronic devices, we use semiconductors. Okay. Now, dielectric material. What are dielectric material? Dielectric material means material which have dipoles in it. Material which have dipoles in it. Okay. So example for this is what? Mica and glass. Means suppose if you place such type of material in the presence of electric field, when you place such type of material in the presence of electric field, all the dipoles will be arranged in the same direction of the electric field. So that is known as dielectric material. Next is superconductors. What are superconductors? Superconductors. So there are some material, where when your temperature of the material is 4 Kelvin, or we can say approximately T is equal to minus 269 degrees centigrade, which is not possible at normal situation. Either we need to use liquid helium or liquid nitrogen, something like that. Then we can take that material to very low temperatures, very low temperatures. In the freezer also, we go up to only minus 20 or minus 30 or minus 40. But there are certain methods by which we can take the material to very low temperatures, around very low temperature minus 269. So this experiment was demonstrated by Kamerlingh-Onnes, and this particular property is known as superconductors. Means here resistance of the material will become 0 and current remains constant. Resistance of the material will become 0 and current remains constant. Such type of material is like gadolinium sulfate. There are some materials like this, okay, which obey which have this particular phenomenon. So resistance of the material is 0 and current remains constant. There is no change in the current. Current remains constant for a long time. So Kamerlingh-Onnes, he did this experiment for which he got the Nobel Prize. What he did, he just took a small ring and he just allowed the current to pass and he removed this wire. First, the current was made to pass through the ring, and then he removed that wire. Then he saw that the current was flowing in this for a long time, and for a long time. Then for this particular concept, he got the Nobel Prize. And this particular concept is used where in now the latest they want to find out the wires, superconducting wires. If they're successful in in manufacturing or manufacturing of these superconducting wires, then we can save a lot of electricity. Instead of lighting one city, we can light 3 cities now. That much current can be saved if we are able to demonstrate superconducting wires. So these are the material. Once again, see quickly. What are conductors? What are conductors?
Materials that conduct electricity or current.
Material which conduct current or which allows the passage of current or which conducts electricity are known as conductors. Okay, what is the example? Metals like copper, aluminium, silver, gold. These are the examples. Then what are insulators?
Which do not conduct current.
Yeah, which do not conduct the current. Example for this is what? Wood, plastic, and rubber. These are the examples. A dry one. Okay. Next one is semiconductors, which the material which allow very small amount of current. It is in terms of microampere or milliampere. Milli, what is the value of milliampere? How much it is? 10 to the power of 10 to the power of how much? Milli means. You're going to write the exam, right? Board exam.
10 to the power -3, right?
-3. Yeah, very good. What about micro?
-6.
-6. Very good. So milli means 10 power -3 and micro means 10 power -6 amperes. So this is the value. Next is dielectric material. When you place such type of material in presence of electric field, they start aligning in the direction of the field. So example is mica and gold. Generally, these we use in capacitors. What is the purpose of this? When you place a dielectric material between the two plates of the capacitor, what will happen?
The dipoles will align and they will move towards the higher charge or the.
Can we increase the capacity of capacitance? When you place a dielectric material between the two plates of the capacitor, can we increase the capacity of capacitance?
Yes.
Yes, we can increase the capacity of capacitance. Okay. Next is superconductors. In superconductors, T is equal to 4 Kelvin. As I told you, very low temperatures. At that time, current remains constant and resistance of the material will become 0. So this is known as. So what happens when you place such type of material in a strong magnetic field? What happens? It repels the magnetic field. So superconductors are acting like a diamagnet. Okay, these are superconductors. Okay, so superconductors are also acting like diamagnetic material. We studied this also in the magnetism chapter. So they are also acting like diamagnetic material. This particular concept of superconductivity is used in maglev vehicles. What is the meaning of maglev? Magnetic levitated train. Okay, magnetic levitation. Maglev vehicles. This particular property is used in maglev vehicles. Magnetic levitation means the train is lifted due to the powerful magnetic field or powerful repulsion. The train or the compartment of the train gets lifted up above the track around 4 inches and it like floats in the air. So the speed of the train is around 500 kilometers per hour. It is in the super fastest train in Japan. Okay, the name is bullet train, which is almost 40 years old. Okay, so please copy this. Then we can quickly go to the next concept, that is resistivity, conductivity, and all. So we'll do conductivity, resistivity, then we'll go to energy level diagrams. So before going to that, we have to discuss about the third A group element, fourth A group element, fifth A group element, what is core electron, valence electron, and all. Okay, but it is very simple chapter. Don't worry, there is no derivation in this. There is no derivation. Only you have a circuit diagram, you have a waveform. That's it. Not more than that. No. So here, So where are these semiconductors used? Semiconductors used everywhere. You know, your laptop, tablet, charger, adapter, the microwave oven, the circuit, the washing machine circuit, everywhere we are using semiconductors, even in a TV, tape record, or a CD player, everywhere. Now we cannot think a world without electronics. Okay, in router or in the Wi-Fi kit, everywhere we are using semiconductor electronics. Okay, but it has a level. What is that level? Let's start with micro. See, first, when you speak about electronics, we start with semiconductor microelectronics. Microelectronics means we speak about only diodes and transistors. Then comes ICs, integrated circuits. Like we have chips, 8-pin IC, 16-pin IC, 14-pin IC, 28-pin IC. There are different pin ICs. Then after that, we have microprocessor. Okay, which can perform operations like in calculator. We have a microprocessor. It is 48-pin IC. Next, we have microcontroller. You will study about this. You will come across this code at a higher level, not now. Microcontroller, it is in in microwave oven or washing machine or in a TV. Why? Because it has specific operation. You cannot change that. And calculator, you can change the values. You want to add, you want to subtract, you want to multiply, or you want to divide, or you want to apply some logarithmic operations or trigonometric operations. You can do it with the calculator because it has a microprocessor in it. Whereas when you go to microcontroller, in microcontroller you have fixed operations. You cannot change anything. From your end, you cannot do anything. Like suppose a washing machine has a separate, like it has 25-minute wash, 30-minute wash, 1 hour wash, like something. Fixed values are there. You can only rotate the knob and fix the values. You can't change it. That's not possible because it has specific functions. Even microwave oven also. It has specific functions. TV also. You can either increase the brightness, decrease the brightness, increase the volume, decrease the volume. That one. There are specific operations. So that is about microcontroller. Understood? So starts from micro. First micro, then IC. With ICs made from micro. Microprocessor made from ICs, like that. Okay, they are in that way. So as we go ahead, one second. Now, now here, okay, we'll start with core electrons. Before that, resistivity. What is resistivity? What is resistivity?
Resistance of a specific material.
Yeah, resistance means resistance of a wire of unit cross section. Per unit length. So we already know that R is equal to rho into A by L. Is that clear? R is equal to rho into L by A by L. So unit is what? Ohm meter. Unit is ohm meter. Next is what? Conductivity. Sigma. Okay. So reciprocal of resistivity is conductivity. So sigma is equal to 1 by rho. Unit is what? Siemens per meter. Okay. Or we can also write per ohm per meter. Siemens per meter or per ohm per meter. We can write like this. So if we speak about conductivity and resistivity of metals, semiconductors, and insulators. So here, if you see for the metals, example, for metals, how it is, the resistivity is approximately 10 power minus 2 to 10 power minus 8. ohm meter. Means it very less. And resist and conductivity is 10 to the power of 2 to 10 to the power of 8. Siemens per meter. Means its conductivity is very high and resistivity is very low. Coming to insulators. In insulators, we have resistivity is equal to how much? 10 to the power of 11 to 10 to the power of 19 ohm meter. Okay. And conductivity is how much? It is 10 to the power of minus 11 to 10 to the power of minus 19 Siemens per meter. So this is very, exactly opposite. Resistivity is very high and conductivity is very low. Now we'll see semiconductors, how it is. Then we'll quickly move to core electron and all that. Okay, core electron and valence electron. Now, in semiconductors, the resistivity is rho is equal to 10 to the power of minus 5 to 10 to the power of 6 ohm meter. And conductivity is 10 to the power of 5 to 10 to the power of minus 6 Siemens per meter. Now, so these are the values. Okay. So you can see here semiconductor values are somewhere between insulators and metals or insulators and conductors. Okay. Copy this. So we'll go ahead now. We'll go with core electrons and valence electrons. Okay. Going ahead with the next concept, that is core electrons. So, what are core electrons? What are core electrons? Electrons close to the nucleus. Electrons close to the nucleus. He is known as core electron. Next is valence electrons. What are valence electrons? Electrons in the outermost shell. Outermost shells. Electrons in the outermost shell of an atom are known as valence electrons. Okay, are known as valence electrons. Now, when I say valence band, okay, before going to this, I would like to explain third A group element, which is also known as 13th group. 13th group. What is that? What are the elements in third A group? Boron, aluminium, gallium, indium, and helium. Here, boron is a gas and thallium is a radioactive element. So we don't take this for the manufacture of semiconductors. Okay. So what? How many electrons are there in the outermost shell in third A group element? Yes, please. How many electrons are there in the outermost shells of this particular group? This is in chemistry basic, yeah? Basic chemistry. No one? How many electrons are there in the outermost shells of boron or third group elements?
1 electron.
Third A group element. You people are going to write board exam now.
Oh, 3.
Yeah. 3 electrons. Who told?
Sir, me.
Please answer something. Okay. So in third A group element, there are 3 electrons in the outermost shell. Okay. There are 3 electrons in the outermost shell. What about fourth A or 14th group? How many electrons are there?
4.
4. But what are the? Can you tell me the name of the elements? Anyone?
Carbon, silicon.
Yeah, it is carbon, silicon, germanium, tin, and lead. But again, carbon is a gas and lead is a radioactive end product of radioactive elements. So we don't take that. Fifth A group element. This is also known as 15th group. 15th group. So What are the elements in this, Dhruti? What are the elements in this fifth group element? This is from the periodic classification table. Can you answer this one? Ashas?
The phosphorus,
Yeah, phosphorus,
antimony,
phosphorus, arsenic. Phosphorus, sorry, nitrogen, phosphorus, arsenic, antimony, and bismuth. It has 5 electrons in the outermost shell. Again, nitrogen is a gas and bismuth is a radioactive element. Okay. bismuth is a radioactive element. Okay. So we have third A, fourth and fifth A group elements. Is that clear now? So this is about so this plays an important role in the preparation of semiconductors. Now suppose I want to make you tell, that is I want to tell you, like suppose we are taking sodium, and how many electrons are there in the outermost shell? How many electrons are there in the outermost shell? So for sodium, yes. How many electrons are there in the outermost shell for sodium? Valence electrons, I mean. Yes, for sodium.
So sodium valence is 1.
Only 1 electron, right? 1 electron in the outermost shell. If you go to the octet rule, neon is completely filled. Then only 1 electron is left, right? So if I am taking 1 gram of a substance, sodium, how many electrons will be there in the outermost shell? If I am taking 1 gram of a substance of sodium, there will be million of electrons, right? Million of electrons in 1 gram in the outermost shell.
Yes.
So, but for this, you have to go to the mole concept again. How to go to the mole concept? So, small n is equal to m by capital M. This is the formula, right? This is the mole concept formula, number of moles. Now, suppose 23 grams, yeah, 23 is the mass of the sodium, has Avogadro number of atoms, right? 1 gram has how much? First of atoms, I want to find out the atom, not the electrons. So we'll just multiply 1 into this value divided by 23, you'll get some value, let it be x. So that many x number of atoms are there. Means what? How many electrons are there in the outermost shell now? How many electrons are there in the outermost shell now? For sodium. For 1 atom, 1 electron. If there are x number of atoms, how many electrons? Are you understanding this concept, the mole concept? See, the atomic mass of sodium is 23. If I am taking 23 grams of sodium, it has how many atoms? Avogadro number of atoms. What is Avogadro number? What is Avogadro number?
6.022 into 10 raised to
Very good.
23.
6.022 into 10 to the power of 23 atoms. So 1 into this multiply divided by 23, you get x number of atoms. Maybe I don't know, billions of atoms again. It will come in millions, or more than that also. 10 to the power of 23 around. That many atoms will be there in 1 gram of. For 1 atom, how many electrons are there in the outermost shell? For 1 atom. This one.
1 electron.
1 electron. 1 atom, 1 electron. Million atoms, how many electrons?
Millions of
Million electrons.
electrons.
Okay. Million atoms, million electrons. Okay. Is that clear? Is that clear? Once again,
Yes, sir.
did you understand the concept of this first of all? Why they are not going with chemistry concept? Instead of going with chemistry, they are making it little simple. If you go with chemistry, then you have to bring mole concept. Mole concept means, like if sodium atomic mass is 23. If you take 23 grams of sodium, we have Avogadro number of atoms. 1 gram, I don't know how many atoms. So just cross multiply to get that value. So you get that many atoms. For 1 atom, 1 electron in the valence shell. So million atoms, million electrons in the outermost shell. Understood now? Is it clear?
Yes, sir.
Now suppose if I take aluminium, 1 gram of aluminium. Okay, so for one atom, how many electrons in the outermost shell?
3
3
electrons.
electrons. If I take silicon in one atom, how many electrons?
4.
4. And for phosphorus, arsenic and all, how many electrons in the outermost shell?
5.
5. Very good. So we have for third group element, there are 3 electrons in the outermost shell. For fourth group element, there are 4 electrons in the outermost shell. And for fifth group element, there are 5 electrons in the outermost shell. Now suppose if I am taking 1 gram of any substance, so 1 gram of this one, it has like I have to just, if I am taking one example of aluminium, what is the atomic mass of aluminium? It is 20, how much? 27, 1327, yeah. That is 27. Atomic mass is 27. Means what? If I am taking 27 grams of aluminum, it will be Avogadro number of atoms. 1 gram is how much? So multiply 1 into 6.023 into 20 to the power of 23 divided by 27. Divided by 27. Is that clear?
Yes, sir.
Okay. 6.023 into 10 to the power of 23 by 27. So that many atoms are there. So maybe let it be I'm writing just as x, some value as x. So for one atom, how many electrons are there? There are 3 electrons. For x number of atoms, there will be how much? 3 into x number of electrons. Is it not? Is that clear?
Yes,
For
sir.
x atoms now, there will be this many electrons now. So instead of writing every time this calculating and all, they made a simple term called band. Simple, in simple words. They say that it is a band. Understood now? A band, conduction band means, sorry, we have valence band. Valence band means a band formed due to the valence electrons. Now I'm not going to calculate now. I'm writing a simple, specific, a general term. That is what? Band. Is that clear now?
Yes, sir.
Calculating this every time like this is becoming a very lengthy process every time. It's very difficult to calculate. So they said that band, what is band? Energy level band, or we have in the valence band. Valence band means a band formed due to the valence electrons is known as valence band. Then what is conduction band? The next higher band to valence band is said to be conduction band, and which is responsible for the flow of current, flow of electrons, or flow of holes, whatever it is. Is that clear? So copy this one.
Yes.
Then we'll quickly go to the band concept. Okay. Are you understanding?